we're going to take a look at the homework that we had, worksheet number 17, specifically on that worksheet. We're going to take a look at number 8 and number 11. Number 8 says, determine the speed of light in crown glass compared to the speed of light in quartz glass. The only thing we know about crown glass and quartz glass, on the surface at least, is the indices of refraction that we can get from the chart on the previous page here. The index of refraction for crown glass, we're going to say is 1.52, and the index of refraction for quartz glass, we'll call it NQ, is 1.47. Now, we don't know the speeds. It would be nice if we did, because when we want to find the ratio of the speeds in crown glass to quartz glass, the ideal is we just divide them, right? We just divide the speed in crown glass to the speed in quartz glass, but we don't know what those are. Does anybody have any ideas? How can we find that ratio without knowing what either one of those speeds are? Why don't we try to find the speeds? Let's say N for crown glass is equal to C over V for crown glass. Does that make sense? We know what this is. We know what this is. We can solve for V. It's going to be something smaller than 3 times 10 to the 8 meters per second. I don't have it written down on my answer key because I didn't do the question this way. Okay, this is the way, though, that I suspect that most of you would have tackled it. Gives us the value of the speed in crown glass. Let's do the same thing now for quartz glass. The speed of light in quartz glass is, I don't know what it is, but again, we can find it. We know what C is. We know what we know what N is. So we can solve for V in quartz glass. Once we get these two numbers, then we divide the two, and when we do that, we end up getting a value of 0.967. Anybody get that? Okay, did you do it this way? More or less this way at least? Yeah? Anybody do it differently? There is a shortcut here that, be honest with you, if I was in grade 12 and I had the experience that you have, I probably wouldn't have got this either, this shortcut either. This is one that usually comes through experience. You do 1,000,000 questions and things start jumping out at you a little bit more than when you do the number of questions that you guys have done. So if you caught this, man, good for you, because I probably wouldn't have caught it when I was in grade 12. But, never know, somebody might get it. We know that V1 over V2 is the same thing as saying N2 over N1. So if we say VC over VQ, wouldn't that be the same thing as saying NQ over NC? Why don't we just divide those two indices then? NQ is 1.47 divided by 1.52, and when we do that, we get 0.967. So all we got to do is divide the inverse of the indices of refraction, because index of refraction is inversely related to speed. Does that make sense? Anybody kind of thinking that? Anybody? No? That's fine. Like I said, I probably wouldn't have thought that either if I was 17 years old or 18 years old in grade 12 with the experience that you have with doing these questions. Okay, I don't care which way you do it. Okay, the first way is the way that most people would tackle it, but second way is a little bit quicker. It doesn't mean it's any better just because it's a little bit quicker. Okay, number 11 we wanted to do as well, determine the critical angle for diamond. We would expect the critical angle for diamond to be relatively small because, as Parker said earlier on, there is a big difference in index of refraction between air and diamond. The bigger the difference in index, the smaller the critical angle. Big difference here, we're going air is 1.00 and diamond is 2.42. Big difference in index, small critical angle. Now, which way are we going here? If we get total internal reflection taking place, then the critical angle will be this angle right here at which the reflection begins to occur. Which way are we going? Are we going from air to diamond, or are we going the other way around from diamond to air? Has to be diamond to air. You have to go from a high index of refraction to a low index of refraction. Can't go the other way around. If you go the other way around, N goes up, theta goes down. You need theta to go up. You need the angle of refraction to be bigger than the angle of incidence if total internal reflection is going to occur. So this is going to be n1, and this is going to be n2. We're going to write down our Snell's law equation, sine theta 1 over sine theta 2 equals n2 over n1. We're going to change theta 1 to theta c, the critical angle, over, what's theta 2? What's theta 2 when the critical angle occurs, when total internal reflection begins to occur? 90 degrees. And 2.42 over 1.00, is that right? No, it's not. Let's pretend, though, that I made that mistake and didn't catch it right now. I go to enter that into my calculator. What's this? And I go to enter that into my calculator. By the way, what's sine 90? 1. So we can, that just disappears, right? We can cross that off if we want. Go to sub this into my calculator. I'm going to go inverse sine of 2.42 over 1. Look what happens on my calculator. I get an error. If I get an error on my calculator in a total internal reflection problem, it means that I have mixed these up every time. If you get an error in one of these problems, it means you've got your indices of refraction backwards. So it's a nice little gift to us. We make a mistake, our calculator tells us we've made a mistake. Okay, go back and switch them. 1.00 over 2.42. Now, when I take the inverse sine of 1 over 2.42, then now I get a number, 24.4 degrees. In every refraction problem, any Snell's law problem, there's always a check to see if your answer is reasonable. Because remember, as n goes up, v goes down. So you can always check it. But this is more obvious. See, our check here is, does my calculator give me a number? So in a regular Snell's law problem, do your check. Is the answer reasonable? As n goes up, v goes down, lambda goes down, theta goes down. But when you're doing a total internal reflection problem, you get an error on your calculator, you know you've done it wrong. You don't get an error on your calculator, you've done it right. Simple as that.